Good morning, everyone, and welcome to Elevated. I am Nate Cruz, your moderator, and it gives me great pleasure to host this monthly Elevated Zoom meeting event. Elevated is CTMM's streaming meeting designed for technology leaders who are passionate about staying informed on industry trends, embracing new ways of working, product innovation, and agility. Our discussions are aligned with our great list of custom course offerings from the prestigious Caltech CTME learning program. Today, we have a captivating talk entitled AI and AL and ML Teams, Navigating the Evolving Roles and Responsibilities by one of our outstanding instructors here, Nicholas Beaudoin. Nick is a senior instructor in the Caltech CTMM program for AI, and he's also the director of the AI programs, bringing in great content and great programs for you to learn from, which you'll learn at the end of this presentation. Mr. Beaudoin's expertise resides in the following domains: end-to-end machine learning, life cycle, machine learning deployment, cloud and WS and Azure integration, DevOps best practices, machine learning operations, applied generative AI learning models, and machine learning open source kits. His experience comes from many years of helping companies ideate, build, and deploy machine learning solutions and their infrastructure. He's helped numerous Fortune 500 companies such as Mercedes, Honda, Warner Brothers, Disney, Estee Lauder, and many national providers from the insurance company and the Department of Defense and the Department of Agriculture. Mr. Beaudoin holds a master's degree in international affairs. He also has a degree in economics and modeling from the University of San Diego. He has a bachelor's degree in political science, and he holds numerous advanced certifications in AW and Google services. So without further delay, I invite Nick to take over the virtual stage. Nick, the floor is yours. We're eager to hear about your AL and ML team and their evolving roles.
Great. Thanks, Nate. Hey, everyone. My name is Nick Beaudoin. Give a quick introduction. I apologize about the stream up here. I come from a Google shop beforehand, and Google sometimes does not play well with PowerPoints. So I don't particularly say that I'm a maven when it comes to slides. There's people smarter that help me with that. But a little bit of background about myself. I've worked half my career on assisting federal agencies like Department of Defense, Department of State, even down to National Oceanic Atmospheric Association. But also a lot of captivating industries around, be it entertainment, communications, or automotive, and really helping companies not only deploy at scale various machine learning and AI capabilities, but support the infrastructure underneath. I've had a blog for a number of years. Most of my writing now is with Caltech CTME. Feel free to link in with me on LinkedIn. I'm pretty active there and try to share a lot of not only the courses that we offer, but some of the things I see in the industry from day to day. Just recently released a white paper called The New AI Team. It's a quick read. It's only about 4 or 5 pages that talks about this paradigm shift that we're in right now, having traditional machine learning life cycles teams, our data science teams, and now this new advent of generative AI and what that means for how we hire AI engineers and the different hiring roles that a lot of product managers and project managers have to deal with from day to day to have successful teams. But I like to bring it back a little bit. Like, why are we in this moment? Why do we hear about AI ad nauseum? Every conference you go, it feels like it's just AI on repeat. And my hope is that we can define some of the differences between machine learning, AI, how it comes together, why we're in this moment. And really, there's 5 different things that have been happening in the not so recent past. And the first one is data. We are in a treasure trove of the amount of data that we're generating. The chart here is showing that 402 million terabytes of data are created each day. This comes from IoT sensors, from things like a Tesla giving sensors from their different types of components, all the way to roller coasters that you would have in an entertainment park. All of these are providing data day in and day out. Cell phone telemetry, the different apps that you're using. And if you think about it, this chart here on the side axis is a zettabyte. A zettabyte is equal to 1 sextillion bytes. That is a tremendous amount of zeros. And so leveraging that amount of data has allowed us to create some of the applications we have today. The second thing that has created this moment, this kind of quintessential moment of generative AI and AI teams, is the ability to rent your compute. It used to be that if you were a company in the 2000s and early 2010s, you didn't have access to high-end compute. Your compute lived in the closet. I remember one of the first companies I worked at, over the weekend, the teams used to have to turn on the fans and open the doors to the servers just to ensure that the compute could hit capacity. Now we're at a point of a click of a button, be it AWS EC2 instances, be it Google Cloud's capabilities or Azure instances. You can just spin up your own instance and have the ability to rent that compute. And we didn't really see that beforehand. Not only that, but that has been tremendous power around the amount that machine learning teams can take. A recent example that's very close to Caltech is Dr. Fei-Fei Li's lab. Fei-Fei Li got her PhD at Caltech, then went on to Princeton, but there was a problem that her and her team had in creating, essentially labeling millions of different images. And these images they wanted to be able to do to predict, to classify if something was a horse or a plane, 10,000 different categories. And in 2009, her team was working with graduate students to create something called ImageNet. Now, you don't have enough graduate students in the world to stay up all night and offer free pizzas to be able to hand in and go and select every different image and say if it's a horse or a plane or whatnot. So what they did is they rented it out. And they went on the open market on something called AWS Mechanical Turk. And Mechanical Turk allows you to send out to a bidding market to have others do your work for you. And when I say do your work for you, I mean label those images. So the ability to both rent compute and to rent out tasks that are usually labor intensive allowed Fei-Fei Li and her team to create something called the ImageNet competition. And that ImageNet competition launched in 2012, allowed different teams to come in and try different types of algorithms to predict what is this a picture of? And over time, we saw champion models truly expand how fast computer vision was going. So this is a microcosm of how renting compute and renting computational capacity allowed us to move to this moment. So we've had data, transcendence of large amounts of data. We have the ability to rent compute. And then it also brings us to the ability to use that amount of data and compute to create novel algorithms. Now, the introduction of what's called a neural network, or in layman's term, essentially modeling how the brain works. I know that's not truly exact, but at a large high-level definition, that's what we're doing. Algorithms like VGG16 that came out of ImageNet competition, all the way to the transcendental paper by Google for the transformer model that allowed us to have generative AI in the paper Attention Is All You Need. So now we're starting to see algorithms from the 50s, from the 60s, 70s start making their way into using it in daily life. And we see that from the most recent Nobel Prize winners in Geoffrey Hinton and John Hopfield. John Hopfield, Caltech alum as a professor. Geoffrey Hinton really laid the groundwork when it came in the 1980s for the creation of, or building upon, neural networks to be able to use it for computer vision. So advances that we had in algorithms in the 1980s and 1990s, we're just now recently able to see its power because of data, compute, and algorithms. Also hardware. This is a screenshot from February. I probably should have updated it a little more to show NVIDIA's true growth. Unless you've been living under a rock, NVIDIA is a semiconductor design company. So they're not actually building chips. They are designing chips which are made by companies like Taiwan Semiconductor Manufacturing Corporation, TSMC, out of Hsinchu, Taiwan, most recently relocating factories in Phoenix, Arizona. So this globalization of the supply chain when it comes to hardware is one of these catapulting trends that we're seeing that allows us to create this new stage of AI. So as review, we have data, we have renting compute, we have the use of algorithms that we used to not be able to use too well, and hardware. The final is the open source community. Open source has been the bedrock that many programming languages along the recent decades have been able to explode in this time where we have so many different open source options that sometimes it's difficult to choose from. But MIT license is one of the biggest, Apache, which has Spark and Hadoop. There's a lot of open source, which is actually being led by Meta when it comes to how we generate algorithms, specifically around llama-based algorithms. So we talked about data, we talked about how compute is now being able to be widely used. We have algorithms, we have hardware, and we have, not so recently, the open source community. So bringing back definitions, when we hear AI and ML, what's the difference? Because a lot of the times we hear them used in the same type of sentence to describe the same thing. AI is essentially, the best description I've ever heard was software that learns by example. You give it data that has happened, historical examples, and it learns and it trains an algorithm, and then it tries to do some kind of human task. Now, you might be thinking robots, that's the first thing that comes to mind, Terminator, Skynet. It can be as simple as from the popular Silicon Valley show, this is a hot dog, this is not a hot dog. Is this a bird or is this a cat? Is this a dog or is this a cat? Those are all technically AI tasks. But as we define it a little deeper, we see AI can be a product. And those products can be popular like ChatGPT, it can be Google Vision AI, it can be Alexa, it can be LawDroid, which allows you to automate a lot of discovery and legal processes. It can be something like Charlie AI Summarizer, which is a summarization tool for your documents. Waymo, which is driverless cars. We see that a lot in Los Angeles, near Pasadena. Midjourney, which allows us to create images using these algorithms. And also meta movie generation, which allows you to create movies. All of these are the system. AI is seen as a system, but what builds out this system? So the system is built on machine learning. Machine learning is the doing to create the AI. And we have had decades of machine learning teams. Those are the types of teams that I led, I'd say before 2022, before ChatGPT came out. And there's a very distinct science to this. Machine learning uses algorithms like deep learning, generative AI with a transformer-based model, decision trees, sometimes even business heuristics. If it's one thing, then go this way. If it's blocked, go this way. Those are all relatively under the umbrella of machine learning, but then there are those who will say, no, it's not machine learning, it's just an if-then statement. And all of these different types of algorithms is just to go to show you that machine learning is the bedrock that helps us create an AI system. And machine learning and AI is not necessarily something that you say, okay, I'm just going to create this machine learning algorithm and it's going to power my AI system. There is a tremendous amount of difficulty to getting the machine learning system to be able to work with the entire enterprise system. And this is something we saw after ChatGPT came out in November 30th, 2022. Companies said, all right, data science team, machine learning team, go to work, make us a chatbot. And immediately a roadblock was set up that this chatbot, this use of generative AI, would be held up in muck because of the system constraints that many organizations had. Startups have less constraints when it comes to how big the system is. But if you start thinking a medical clinic that has enterprise systems that might go back 40 years, you're not going to be able to put an AI system very quick. There are a lot of different stakeholders. And for those who are project managers or product managers, you need to think, how are those stakeholders going to talk with the AI and the ML team? More so, how do you talk to an AI team versus an ML team? How do you hire those roles? These are all questions that started after 2022 as a lot of companies started experimenting with generative AI. But the traditional machine learning team, our quote unquote data science team, is based on a machine learning lifecycle. And this is a tried and true scientific method practice. And I'm going to go into that real quick here. This is how we thought about predictions. Predictions come from 1957 when we started what's called the perceptron, which was the grandfather, great-grandfather of today's neural networks. We've done things like decision trees or convolutional neural networks, random forest. All of these have led to where we are today on how we predict. We use different algorithms to make predictions for a business. And we've used historically open source tools. So before kind of ChatGPT, we used tools mainly around R and Python. Those were the bedrocks. Normally, R would be used by teams that came from academic backgrounds. You saw this a lot in nonprofits. You saw this a lot in political polling firms that have a lot of academics. You saw this a lot in government agencies. Anywhere there were links to academia, you tended to see R, a very good statistical software, not so good when you need to put machine learning into production. And that's where Python came in. Python allowed you to do things like create machine learning life cycles, all the way to productionalizing and helping build out websites. And one of those tools that data scientists and machine learning researchers focused on so heavily on machine learning teams was scikit-learn. Scikit-learn was a package that allowed you to use out of the box many of the algorithms from decision trees to random forests to support vector machines that allowed you to do relatively complex types of algorithms with minimal coding. In 2015, Google decided to launch TensorFlow with a lot of funding and backing, but recently we've seen PyTorch being used more and more. A little plug for Caltech CTME, we teach a course called AIML for engineering and science, which is a 40-hour course that's taught on Saturdays, and it uses PyTorch and scikit-learn to be able to teach folks who might have been in the labs for the last 20 or 20 years to use what industry tools are using. Maybe they've used MATLAB, maybe they've used Mathematica, and they want to see what's being used. That's one of the courses that we offer. But some of these tools were also closed source, be it SAS, SPSS, IBM, MATLAB. It's very difficult when using traditional closed source tools to do modern AI deployments. And what these machine learning teams are and have been focused on, like I said, the scientific method. We make an observation, we find a research area, we form a hypothesis, we test with our algorithms. It could be scikit-learn, TensorFlow, PyTorch. We analyze that data and report. We report our evaluation metrics. How good was our algorithm? And this looked like a machine learning lifecycle. So the scientific method essentially is data science. It is, we're using scientific method with data to identify some kind of anomaly or prediction that we want to make. We collect the data, we pre-process that data, we draw pretty pictures of what that data should look like, so exploratory data analysis. We create features, we then select a model, we tune that model, and we evaluate it. So how do we put something into production? Well, that model is given into an API, which is allows us to be able to put it into a system. So this is how machine learning essentially builds an AI capability. But this is where things started to change. In 2017, there was a seminal moment with a paper by Google called Attention is All You Need. And Attention is All You Need was built on the backbone going all the way back to 1957 for the first perceptron, and slowly metamorphosized throughout its career by the 1980s by now Nobel Prize winner Geoffrey Hinton to leverage neural networks with various components that we've learned over the years. And in 2017, ChatGPT didn't just come out. Remember, generative AI is built on the transformer method. It took a while. In fact, GPT-1, which was the first algorithm for ChatGPT, wasn't created until 2018. You might be thinking, hey, wait a minute. I thought it was late 2022 that ChatGPT came out. That was actually GPT 3.5. And the reason it did so well was because OpenAI decided to put a nice, simple user interface for internal testing to be able to use it. And from there, it's just history how fast that application took off. And just like I said, we see ChatGPT in November 2022 based on the lineage of architecture that had come before it. So what does this change? Can we still have a machine learning team put into production generative AI solutions, or does it take a different type of toolkit? And that's originally what the white paper from CTME shows, is the machine learning team and the AI team are two relatives of each other, but they're not the exact same formation. And I think it's important as a project manager or a hiring manager to be able to understand how you hire for those roles. Because this toolkit and the suite of tools that you need to manage as a hiring team has completely changed. There are elements of data science and machine learning, but if you are productionalizing generative AI, it is light years different to the toolkits that you need to be hiring for. So how is generative AI created? In a very high level, on the left-hand side, we take data. This can be from text, this can be images. These are scrapings from online. Essentially, think of it as a large part of the internet being trained on a model. And it's not the type of models we built with sklearn or PyTorch or TensorFlow. These are models that are taking a very, very long time to train. They're not cheap, too. This is not something that a mom and pop shop is going to be able to train on their own. There are elements that they can take a pre-trained model that someone else has done and change it to their likings, but they are not going to be trained what we call a foundation model for their deployment. You're going to see that from large companies like Bloomberg. You're going to see it from large companies, Google, AWS, Azure, Alibaba. You're going to see Oracle, IBM, and you're going to probably see a lot of national security agencies in the US government creating their own. And it's a lot of money. If you look at the graph right here, if you look on the left-hand side when the transformer model was released by Google, the training cost was just over about $1,000. If you go all the way up to GPT-4, which the current ChatGPT runs on, which is GPT-4 Omni, it is nearly 100 million with an M dollars to train that. Now we're starting to realize issues around responsible AI. Specifically, responsible AI deals with things like bias, fairness, transparency, security. In fact, if you ask Amazon, Google, and Azure to define them, they will not line up one-to-one. Responsible AI is still an area that is very much being determined by laws, regulations, societal constraints, and environmental constraints. The amount of environmental power, I'm sorry, not environmental power, but the amount of electricity that's needed for the training of these algorithms is something that we've never seen. Being able to chain tens of thousands of GPUs together to train one foundation model is something that we've never done in human history. But also, we have never created tools that assist our knowledge in human history. We've created things that help our hands. We've created things that help mundane tasks or us do things faster and more efficiently. But we've never created things that help our mind augment how we go about thinking about tasks. And this is the paradigm shift. On the left-hand side, you have a machine learning team. Those are ML researchers, those are ML engineers, those are data scientists. Most of us in the industry of machine learning, data science, AI, we all got our start in different areas, but we all come together as using the scientific method to help augment the data that we have to create predictions. And as we train and curate the model through the scientific method, the endpoint is an API. The API is how do we connect to a system? How do we connect to the behemoth of enterprise systems that a large company would have? Or something very, very small that might be a Flask, Django, or Streamlit wrapper that a small mom and pop shop is using. On the other hand, because generative AI is so difficult to train and create, and very few companies are able to do that, what we call the moat. Because it's inside this moat, it has to be pre-trained by somebody else. And essentially, we are borrowing that model. We are paying a very small amount every time we call that model. And that's why AI engineer sits on the right-hand side of the API. The API is what you use to be able to leverage the model. Whereas on machine learning teams, we created the model. We used sklearn or TensorFlow or other open source tools like PyTorch or closed source tools like MATLAB, and we tuned the model and created it and evaluated it and shipped it as an API. But now the practice of generative AI happens after the API. You are no longer training these models. These foundation models are made for you. You bring it down as an API, and then you need to integrate it with your system. Now, these are very wide terms. Of course, you do have open weight models that allow you to bring it in, like Llama 3.1 and 3.2 from Meta. You can own the weights, but open source is not the same when it comes to those. You don't get the data. You don't know what it was trained on, and you sure enough don't get the code. So even the open source community is changing on how we define what open source licensing looks like. The way that you hire for an ML team versus an AI team is based on this chart. You are taking the pre-trained algorithm and leveraging the API. And that is why the AI engineer and the full stack engineer are so crucial to the development of generative AI technologies at your company. Whereas on the left-hand side, we follow the machine learning lifecycle and the scientific method. Over on the right-hand side, we very much focus on how do I put this into the hands of the user and software engineering best tool practices. The way that we think about how we go about creating products has changed as well. On the upper side, we have a traditional ML team. It starts with the data, it moves to the training of the model, and then it moves to the productionalization. Whereas when we have a large language model or a foundation model, we start with the product. What do we want users to use? We get data from that, and we use that data to build a model. So what does this look like? If you are hiring or you're a hiring manager for AI teams and you are tasked with creating some kind of chatbot or summarization tool or agent-based AI system, you need to think about how you're hiring these teams. In early 2023, the data science teams that I led and that I was on, we did a lot of experiment. We were grabbing these APIs from these pre-trained models and trying to determine, okay, how can we wrangle this? How can we use this in our traditional machine learning lifecycle? And we quickly realized that we needed a new set of tools. And those new sets of tools were how we prompt these models. You might have seen, hey, here's 10 steps to become a prompt engineer. I hate to say it, this job does not exist. Maybe one or two companies hired a prompt engineer. Prompt engineering is something that's relatively straightforward to learn. It's how you integrate that prompt engineering into a system with software engineering. So hate to be a buzzkill, prompt engineering probably not going to be a role that you're going to see for very long. So what does an AI team actually look like? The machine learning teams that I've led is we always had a technical project manager. That is a project manager who has a little bit of hands-on tooling experience. They know the difference between PyTorch and TensorFlow. They know when to use sklearn wrapper versus using some other out-of-the-box type of algorithm. They understand the cost limitations if you're using different solutions, be it AWS SageMaker or Google's Vertex AI. They know enough to be dangerous, but they're not going to have hands on the keyboard. Maybe they stay up to date with some tutorials, but they're very good at leading technical teams. And I think there's a difference between a technical project manager and a project manager who focuses mainly on agile methodologies, is a Scrum leader, a lot of the things that Elevate teaches. And I really want to make the distinction between the technical PM and the more, I would say, Jira, Agile, Scrum-based project manager. Sometimes you need both, depending on the size of your project. But if this is a smaller, lower mid-sized project, this is the type of team you'd make. You would have an ML platform engineer. The ML platform engineer is really somebody who understands cloud and they understand databases. Because when you're creating a generative AI solution, many of the times you need a new type of database called a vector database. A vector database is really good at taking images, taking pre-processed text, taking video, and being able to embed it into a multi-dimensional representation of that data. It's very easy to query with an algorithm, but it's not the same as hiring, say, a database engineer who has a lot of experience in relational databases. It's a really different type of toolkit. Getting data from one area to another within generative AI requires the ability for the data engineer to understand how algorithms are used for that. So the ML platform engineer is a role that we see a lot for AI teams. The second one is an AI engineer. There's a lot of different definitions on how an AI engineer works, but mainly this is somebody who knows how foundation models via an API are queried. They're very good with prompt engineering on a programmatic level, and they very much understand the different tools that are needed, be it LangChain, Llama Index, if you're on Azure, Semantic Kernel. All of these are tools that help orchestrate the different workflows together. A data engineer, because you're going to have to move data from one end to the other, you're going to have to be able to store it. This data engineer is going to have to know about regulatory frameworks like GDPR and EU AI Act. Finally, a front-end engineer to be able to put a UI UX design onto that. Now, I'm not saying that they need to know design fundamentals, but at least they're going to be able to have some way that your users can use it. That being said, if you can afford it, a UI UX designer goes a long ways. Here at Caltech CTME, we do a lot of partnerships with Art Center College of Design here in Pasadena. And it's a tremendous relationship that we like to flex a lot because not only are they close in proximity, but they're a world-class design institute where they look at design and AI together. So many of our courses combine that capability. And finally, if you really can afford it, having a research scientist. These are those people that have PhDs. These are people that places like Meta, AWS, Google would be hiring by the droves to be able to look at cutting edge foundation models and to train them themselves. So now that you've heard this whole spiel of how we got here through data and compute and the new algorithms, how generative AI has brought us to the new AI team and this not so recent past and current. I might say there's still machine learning and data science teams out there. Don't forget about us down here. Businesses still need to make predictions. What do you do now? So there's 3 courses that are currently available that I'm particularly proud of. One is our AI on AWS called AWS Foundations for Development. This actually kicks off this Saturday. Myself, Kevin Coyle, and Richard Chong Chow, we all created this course because we felt the need for it was very important. It's for people who have a data science background, but want to see how AWS is leveraged. We use a lot of AWS SageMaker, we use Bedrock, and we teach you how to fine-tune a lot of generative AI algorithms. That actually kicks off this Saturday. It's an all-day Saturday course for 3 Saturdays. The second course is called AI ML Lab for Engineering and Science. This is on its 3rd iteration. I'm very proud of how this course has been developed through the different iterations. It's really for people who might have learned MATLAB, Mathematica, SPSS, SAS, and want to see how open source tools are used. We walk you through the entire machine learning lifecycle, but we also introduce various elements of generative AI and how to use that. We also have another course called Large Language Models for Artificial Intelligence. That really breaks down the bedrocks of how generative AI is made. I would say this is a more technical course for people who want to open up the hood and be able to see what's happening underneath. Finally, last slide, I promise, there are 2 courses that we're working on. One is called Prototyping AI. This course is for people who might have already finished a long boot camp. Maybe somebody who works in a company and their boss is saying, hey, it would be great if we had a proof of concept, a POC. It'd be great if you could demo something. It allows users to have a nice front end that a non-technical user can use while teaching you how to build what's happening under the hood. We are looking at launching this in early February, and a lot of hard work by a lot of individuals coming from both Silicon Valley and Los Angeles have helped create this course. Finally, this is kind of stealth mode, but I was too excited not to talk about this. We are introducing what's called an innovation lab. And this innovation lab is for companies who have a predefined use case, and they want to be able to work with Caltech, CTME. They want to hear about cutting edge research from professors on campus, but more importantly, they want to be able to operationalize something. So we bring in professors, we bring in industry professionals, and we bring strategists from the consulting and MBA world, where the morning is dedicated to learning about a transformational technology, and the afternoon is used on how do you strategize that? How do you market that? How do you ensure that it's responsible? How do you ensure that it's hitting regulatory compliance? And those are all different things that we're really excited to have very customized programs in an innovation lab. All right, Stacy, Nate, I'm going to hand it over to you for any questions.
Okay, thank you very much, Nick. Quite an amazing presentation, sir. I would say you covered a lot of information, and not only covered a lot of information, you simplified a lot of concepts and gave us a lot of things that filled in a lot of gaps for even myself, who've been kind of seeking this topic of AI and generative AI. So thank you very much for that. It was worth tracking you down a year ago and finally getting you on the agenda.
Yeah, I think we first started talking about this at a holiday party last year.
Yeah, I did. And, as you were running out the door to catch up with your wife. But anyway, Thank you so much. I think you've been a great addition to our team here. So I'm going to start out with a question here, Stacy, and you can assist and help me if you see anything in chat as far as questions here. So Nick, you've got a lot of great information you provide for us and showing how AI is going to empower the next generation of development activities. But what strategies should managers use to ensure collaboration in between the AI team and other business units, especially when integrating solutions at the enterprise system level? You had mentioned something about you need to have technical skills, and you also may need to have some um, agile skills. What else might a manager need to be able to incorporate to evolve and develop systems using AI?
Yeah, the big one we usually had come up was, I'd say, misunderstandings of what it means to go to production. And so I think understanding the software lifecycle development, and it has a lot of relations to how agile tech methodologies came out, is you have essentially your demo, and that's you call it a POC, a demo, proof of concept, a prototype. Then you have your minimal viable product. What is the minimum requirements that you need to translate to the team to ensure that you're checking off those boxes? Finally, how do you go from that MVP to production? And what does production mean? Because a lot of the times your stakeholder, your client will have a different understanding on what a productionalized system means for AI versus what an MVP or a POC. A lot of the terms about deployment and production are thrown around without defining it. And that has to happen before pen gets to paper. That needs to happen in the contract on what do you mean by MVP and what does a finished MVP look like. Also, I think something that non-technical project managers can get technical on very quickly without a lot of in the weeds experience is the new regulations coming out. Europe's GDPR, California's CCPA, all the way down to, say, New York's local law 144, which states that AI algorithms and HR have to be audited once a year. There is a whole tsunami of regulations for good, and some of them a little constrained coming down the pipe. I'll keep complete personal opinions away from this, but we're seeing Europe with the EU AI Act put some very pivotal laws, especially Article 4, which is going to hit in the first week of February in 2025. And Article 4 states that for your organization, if you're in Europe, you have to have AI literacy training. Article 4 is one paragraph. And so how do you define that with your organization? How do you determine what AI literacy looks like? And I know I keep plugging Caltech CTME, but this is something that we track very closely because we work in the area of empowering organizations through training. So what type of training partner do you need to go through? Does this happen annually? So these are all different things. The final advice I would give, if you're a project manager and you want to get technical, find your maven. Find that person who works in the technical side outside of you that you can become friends with. And I give an example early on in my career. I was working with a company called Analytic Services, Answer. It's a federally funded research and development corporation. Phenomenal company to work for. And I remember as a newer analyst, I would go downstairs to the basement and talk to the website team. I knew nothing about front-end development. And I tried to find like topics that we had in common. I think it was golf, our terrible golf games. And I learned a little bit about what it took from a security perspective and a website perspective to put our content online. And through those conversations, it paid off 6, 8 years down the road when now we're thinking about putting AI systems in front of users. And those same people that talked about golf with, all of a sudden I can ping and say, hey, what's your opinion of this new front end tool? I don't know much about it. Can you get 15 minutes on the phone? So find your local champion, your local maven at your company and try to make friends with, because you can learn a lot through that relationship.
Fantastic. Thank you for that answer on that question, Nick, here. And please do not stop promoting our classes here. That's what the whole intent of this elevated session is here. So we got a question here from William Rowland I'm going to integrate in here. And he says, how do you foster collaboration and communication within AI teams, especially when team members come from diverse technical and non-technical backgrounds? What are your thoughts on that?
brown bag sessions are usually the best. If you can create an incentive, I mean, nothing's worse than stale pizza for a brown bag session. Have some way for there to be a learning experience that is in person or virtual, where you all have your cameras on and you're able to share learned lessons. I think that sharing learned lessons allows us to move beyond a blame game of, I don't know anyone in that department. Why is the product always late? I rely on it to, hey, I know Joe, I know Susan within that department. Let me ping them to see what they're working on. And I think by having those regular occurring brown bag sessions, you can get a lot of cross pollination of the different work streams, but also a lot of the ideation, especially when it comes to generative AI use cases. Every company has a laundry list of different use cases, but they don't necessarily know how it can be used from department to department. I remember I was at Google Next a couple years ago, and somebody from a very large company talked to me, said, hey, I really like your demo that you created with generative AI. It works very well for my division, but we'll never be able to get stakeholder acceptance if you sell it to one division. How can we get two divisions to sign on to it? And so the more cross-pollination you have between divisions and ideas, the faster it will be for adoption for any of your AI or even your traditional ML technologies.
Okay, fantastic. Thank you very much, William. Hopefully we answered your question there. If not, please put another question into the chat. And others that are online here, please, I'm not going to be the only person asking questions. We want to answer your questions here with this valuable resource we have here, who's my soon-to-be new maven on AI, Nick here. So ask any questions and we'll bring it up here. Next question is, what predictions do you see with AI and generative AI in 2025 and beyond? What do you see is the new green field of this whole area?
Whoever figures out regulations and how to predict regulations is going to be at the forefront. Like I said, with the EU AI Act, we saw in California. California tried to pass. Senator Wiener was the one who pushes SB 1047. Gavin Newsom, our governor here in California, did veto it. There was a lot of regulations, pros and cons. The pros were that it was going to allow us to have more responsibility within the AI ecosystem. The downside is many thought that it would stifle innovation and would go somewhere else. I think that understanding how regulations affect you specifically as a business. So for example, one local municipality law that I like to talk about is New York City Local Law 144. And what this states is if you are in human resources and you're using automated and algorithm-based screening tools for your hiring decisions, so you're screening resumes, you need to audit. You have to have a third-party audit your AI system for screening those resumes once a year. And the penalties are quite severe if you don't. It's the Wild West when it comes to organizations that audit AI. There are some nonprofits out there like For Humanity. Babel.ai is another AI vendor that does the auditing of AI algorithms, and there's a handful of other ones. But really, there's no national laws around what creates a proper certification. I think that in terms of models themselves, we're going to see a lot of open weight models. Remember, there's a difference between open source, open weight, and open data. Open weight allows you to download the weights. You can't see the model. You can't see the data. You don't know what it was trained on. Like I said, Llama is an example of that. If you're interested in open weight models, go to olama.com. By the way, no affiliation with CTME, but Olama shows a lot of the open models that you can download. There's a lot of them out there. If you look through the list on their index list, there's hundreds of different algorithms that you can use. I think companies are going to start embracing leveraging local models. However, you need good AI engineers for that. Finally, agents. Agentic AI, I think, is going to push the boundaries. If you go to any conference right now, that's all they talk about. Essentially, an agent is a tool with a large language model. You give it instructions, and it performs tasks on your behalf to specific agents. It can be a calculator. It can be something to make a reservation for you. That is where having solutions architects on your team to be able to architect a solution and see it holistically. As a project manager, guess what? You're going to have to work with all those different teams that your agents touch. So I think agents are going to be really big in 2025. The only problem from a software engineering perspective, we're going to hit a brick wall, is because agents are very difficult to unit test. Software engineering is based on having a deterministic output, 1 + 1 = 2. I can check that time and time again by code. Programmatically, you can check it, you can automate it. Once you talk with agents, now you're dealing with probabilities. The large language model does not work in yes and no's. It works in a probabilistic method. It is sampling from a distribution of probabilities. So how do you test something that has a different probability every time? Whoever can figure that out, I think, is going to go a long ways in their organization.
Okay, thank you for that. And again, folks, we are still asking you to give us questions to be answered from your standpoint. This whole session is for you, so please type in any questions that you want answered. There's no such thing as a bad question. I have one situation here, Nick, as an instructor, as a mentor in many different professional groups, such as business analysts and project managers, and your traditional software developers who become fairly skilled at technology and ways of doing things from the 2000 to 2010 area. And now this whole topic of AI is coming up, and they're being asked to reskill themselves. So from the individual standpoint and from the managers that have to manage their education and development, I mean, what should we prioritize as skills that we should focus on first in this AI-centric workflow or eco center?
Look, I think that we need to be okay with that. The only thing, change being the only constant here. It was in like mid 2000s. Actually, it's 2012 article by Harvard Business Review. It was on, who was it? It was that Thomas Davenport, who's written a whole host of good AI books. His most recent I've got on the shelf is Working with AI. I'm trying to see, it was with Stephen Miller was the person he wrote it with. But Davenport and the Obama's ex head of data science, DJ Patel, they popularized this idea that, hey, data science is going to be the sexiest job of the 21st century. Well, that lasted exactly 10 years. Who knows in the next 10 years what we're going to deal with? We are going to be constantly changing on how these frontier and foundation models change. But in terms of your own education, I don't necessarily think as a program manager and mentor, you need to be learning all these tools. What you need to be doing is reading lots of blogs, listening to podcasts. Top podcasts that I listen to stay in knowledge are Practical AI. Practical AI is led by somebody who created something called, I believe it's like Guardrails AI, and another AI researcher at Lockheed Martin. So Practical AI is usually my go-to. Second one is called Latent Space. Latent Space has a phenomenal blog. Weights and Biases is another good one. And then what's been around for 10 years is superdatascience.com. If you are relatively new to kind of AI, machine learning, data science, check out podcasts superdatascience.com. It was originally started by a guy from Deloitte, Australia, called Kirill Eremenko, and it's now been, I think, given to another person, but they're in like episode 1000 or something like that. So podcasts, talks, different communities, meetups. You don't have to be worried about not understanding what tools. Look, if someone came up to me tomorrow and said, hey, Nick, do you know Lemon XYZ? I'd be like, gosh, what's Lemon XYZ? I got to learn that. It's no longer the state of affairs where you have to know every tool. It used to be easy. You were an R or Python user and you use the packages there. I cannot tell you, I remember one of the conversations on my former team before I joined Caltech was, gosh, I'm worried to go on vacation because what model, what tool is going to be released? That do I have to know what Lemon XYZ is when I come back from vacation? Am I going to be left behind? And the sooner that you realize that you can't know it all, the better that you'll be. Because nobody's going to know every tool in the market. But if you know the fundamentals, like how is a foundation model created? How do I leverage an API versus training the model myself? Those are very basic things that project managers should probably know.
Okay, Thank you very much on that, Nick. God, you're just showering us with knowledge and points of contact here. I'm going to have to make it a point to come down to your office and look up on your shelf on all these books that you keep pointing to make sure I can come up with my reading list. I
Well,
would say,
let me stop you right there. This is a thought that I've been having for the last 6 months, and O'Reilly Press and Manning Press and Springfield might be angry at me saying this, but hey, they don't pay me. So I don't think that technical books are worthwhile anymore. That's because it takes a long time to write a book. The way that the technology stack is changing, but once a book comes out, it's probably going to be old news. Now, there are some books. I still buy it. I still buy some technical books just because I want it as a reference. Podcasts and blogs are where the cutting edge is being released in real time. So don't feel that you need to go buy books. Find a podcast recommended, and it usually takes going through a few stinkers to find it. Send me a LinkedIn message. I'm happy to share kind of the resources that I use to stay up to date. But find your crew, find your mavens, be that virtually or in person.
Okay, and I think what you're asking us, and hopefully I'm not misinterpreting your language, is that you're asking us all to be lifelong learners and to explore into the uncertainties and be able to pick up things quickly. And you don't have to get a deepness into one area of technology or be an I-shaped person. You're going to have to be a T-shaped person that has a baseline of knowledge of maybe technology and business, but also understands and can speak to many different ways of developing products and solutions for a customer, and not go in and per se like be that one manager with one hammer to solve all problems. You're able to reach out in different areas here, and that's a great thing to do. And we really appreciate how you've just jumped in and provided so many training solutions here within Caltech. And trust me, I'm going to end up taking all of them once I get a chance.
And that's what we pride ourselves in our courses. And there's a reason why we rarely put courses online as recordings. We teach them live because we believe that it's integral to update the courses with every iteration. And I can tell you, the folks on the AI team and myself, we are constantly trying to keep our ear to the ground on how to update those courses.
Yeah. One question we have here, Chad asks, Nick, I believe you are teaching and you're creating courseware too. You're doing multiple roles here and activities here. And I believe somebody else asked another question about when will the recording for this be available? I don't have a definitive date, and Stacy, if you could give us specific dates, I would say before the end of the year, there should be an available recording that we have out in a professional fashion that you can go out on the internet and access here. We'll keep you abreast of when that's available.
Yes, that's true. And also I want to let everyone know who is attending on this call. We will be actually all registered people will receive an email with this presentation, the PowerPoint presentation, and the recording, probably within 2 weeks, maybe sooner.
Okay, thank you very much, Stacy. Doing a wonderful job of answering that question. I could not. So, Nick, at this point, we have a couple minutes here. You've already handled some of the things we would do in this time period of what courses that you have available. So you've done an amazing job of covering the topic and let us know where they can reach out to you and train. What getting off the stage or final topic that you'd like to let the people know about that you haven't had a chance to bring up with before we got into the Q&A? What you're getting off the stage final message?
The best thing to do is surround your people with that work in different points of both your research, your sales, your organizational constructs. I mean, you find your maven in each vertical. And even more so, something that I spend a lot of time thinking is who are my mentors and who am I mentoring? I like to have 3 levels. I like to have somebody who's much, much higher than I am. So maybe they're 10 years ahead, 15 years ahead. This is to be someone in the C-suite. I like to have a mentor at my level. So I have a couple what I consider mentors, and I hope I mentor them too, in different companies around the world. And we check in and say, what tools are you seeing hitting? What are some of the requirements you're seeing? And then also a mentor that's 10, 15, 20 years your junior, because they're going to see tools that you're never going to see. They're going to be seeing the first things in the front lines. And so having those 3 levels of mentors, I think, is really important. And hopefully you can provide that type of mentorship at your respective pieces of your career as well.
Yeah, and I like the way you stated that and broached it, because it sounds like it's bi-directional coaching and mentoring. You bring something
Absolutely.
to them and they bring something to you. It's not you coming in and say, hey, teach me or change me. It's a little bit of something for both sides of the relationship and a partnership, and that's
That's
great.
absolutely correct. Yeah.
Okay, well, if there's no final topics here, thank you very much, Nick, for an amazing presentation.
Yeah, thanks for hosting, everyone.
Thank you for a fantastic Q&A and educating all of us here. We look forward to hearing more about your classes, and I will sit down with you and talk about opportunities for other members of your team,
Yeah.
in specialty areas that come in here. We'd like to showcase them also. So everybody, thank you very much for coming in here in November. This has been an amazing presentation here by Nick here on his topics. We continue to do this every month, coming up with the last one of the month in December. We'll let you know as soon as we have a speaker lined up. But thank you very much for your time and attention. And tell your friends. We want to grow this community and let people know what's going on at Caltech and new emerging activities and be elevated. Take care.